Hi, this is Dr. Jivikas Paul. We are now going to discuss about one more topic in ILD, maximum shear force, maximum positive shear force and maximum negative shear force. So here you can see a beam, consider a beam AB of span L, let a wheel load W moves from A to B. Consider any section at the distance x from A. So you can see in the figure there, a W load is moving from A to B on the span. The span is simply supported beam. So it is now at some distance x from A. So now maximum negative shear at x. For this condition, the load W should be placed just to the left hand side of the section. So maximum negative shear force at x equal to Fx equal to minus Rb. So we can take right side or left side. We are taking right side here. So right side upwards Rb is there. So it is minus Rb, that is minus Wx by L. So how we got this Wx by L Rb? So applying sigma moment about A equal to 0, we will get Rb equal to Wx by L. Now, so at x equal to 0, the shear force at x equal to 0. X equal to 0 means at A, the shear force is 0. At x equal to L, the shear force at x is minus W. So it is a downward part. You can see in the figure, the downward part is for the left side portion. So downward part 0 and W, minus W. You can see the triangle, downward triangle, and it is represented as negative. It is a negative shear force. Next, so hence for various sections from A to B, the maximum negative shear force changes from 0 to minus W. After this condition, the load W should be placed just to the right side of the section. So similarly, maximum positive shear force at x equal to Fx equal to Ra. So we know that Ra equal to W into L minus x by L. So therefore, at x equal to 0, that is at A, shear force is plus W. So you can see in the figure also the same thing. At A, it is plus W on the top side, top one. Next, at x equal to L, the shear force at x equal to 0. That is at B. You can see the top one there, 0, W and 0. Positive shear force is there. You can see there. Hence, we can say that for various sections from A to B, the maximum positive shear force changes from plus W to 0. It is maximum positive shear force. It changes from plus W to 0. You can see the top one there. So final figure, you can see there, top and bottom shear forces, negative shear force and positive shear forces. Similarly, maximum bending moment diagram. For the bending moment at section to be maximum, the load W should be placed exactly at x. So we know that the maximum bending moment is L minus x by L into x for unit load. It means W when W equal to 1. But here the load is W. So the bending moment at the section is mx equal to W into L minus x into x by L. So at x equal to 0, that is at A, mx equal to 0, at x equal to L, that is at B, mx equal to 0. But at x equal to L by 2, at center, mx equal to W into L minus L by 2 into L by 2 divided by L, then it is equal to WL by 4. The maximum bending moment diagram is parabola with the maximum ordinate of WL by 4 at the center. Now we'll see a problem on UDL length greater than span length. So when UDL length is greater than span length, how to draw the influence line diagrams. A UDL of 40 kN per meter longer than the span rolls over a girder of 30 meter span using influence line diagram. Calculate shear force and bending moment at 12 meter from left support and also calculate absolute maximum bending moment. So we need to draw the influence line diagram for shear force, bending moment where at 12 meter from left support. Also calculate absolute maximum bending moment. So here you can see the figure there. The span is AB. AB is 30 meters, but the UDL length is greater than the span. So UDL is 40 kN per meter. First of all, let us draw influence line diagram for reactions. So for that, we know that Ra is L minus x by L, so 0.6. Minus Rb is minus x by L, so minus 0.4. So you can see the influence line diagram for reactions there. So Ra value 0.6 at the top, Rb is minus 0.4. So negative shear force and positive shear force upwards, negative shear force downwards. So maximum negative shear force equal to load into area under ILD of negative shear force. That left side part negative shear force take care of the UDL when it is placed towards the left side of the section completely. So here 40, load is 40 into area, half into base into height. Height is minus 0.4, base is 12 here. 12, A distance from A to the section 12. Yeah, that is minus 96 kilonewton. So similarly, maximum positive shear force equal to load 40 into area of triangle, half into base into height. Height is 0.6, base is the remaining distance 30 minus 12. The positive shear force represents the when UDL is placed towards the right side of the section. So it takes care of that. Next, similarly, bending moment. We know that it is L minus A by L into A, that is 30 minus 12 by 30 into 12, that is 7.2 meters. We know the influence line diagram how to draw. So next, maximum bending moment is equal to load into area under the ILD. So 40 into half into 30 into 7.2, 4820 kilonewton meter. Next, absolute bending moment. So bending moment at 15, absolute bending moment means at center. So L minus A by L into A, that is 30 minus 15 by 13 into 15. So you will get it as 7.5 kilonewton meter. So maximum bending moment at 15 meters is equal to load into area of left side triangle plus load into area of right side triangle. Similarly, let us see the other condition that when the length of the load is less than the length of the span. A UDL of intensity 20 km per meter crosses girder of length 24 km having a length of 6 meters using ILD, influence line diagram. Find the shear force and bending moment at 9 meters from the left support and also calculate absolute maximum bending moment. You can see the figure there. AB is a span, there is a girder and UDL is placed there. The length of UDL is 6 meter and load is 20 km per meter. AB span is also shown there. So we need to draw ILD. We know ILD how to draw. So the negative shear force take care of the when the UDL is placed to the completely to the left side of the section, negative shear force is formed, and when the UDL is placed completely right side of the section XX, then there are positive shear forces formed. So in that way we can calculate. So RA is L minus X by L 0.625, RB is 9 by 10 0.375. So when the total UDL is placed to the left side of the section, we will calculate the x1. So how to calculate the x1 using similar triangles. So minus 0.375 divided by 9 equal to x1 by 3. We will get x1 as minus 0.125. Similarly, we can calculate x2. That means when UDL is placed to the right side of the section, x2 is formed. x2 is 0.375. So maximum negative shear force at 9 meter equal to load into area under ILD of negative shear force diagram, that is load is 20 into area of the trapezoid. Then we get as minus 30 kilonewton. Similarly, maximum positive shear force at 9 meter equal to load into area under ILD of a positive shear force diagram, load is 20 into area of trapezoidal, then we will get 60 kilonewton. Similarly, bending moment at 9 meters, maximum bending moment is L minus A by L into A, that means that is 24 minus 9 by 24 into 9, that equal to 5.625 kilonewton meter. So now we will find the ordinates there for the here bending moment. So x3 and x4 using similar triangles, we will find x3 and x4. 5.625 divided by 9 equal to x3 by 9 minus y. But we don't know what is y here, distance. So using similar triangles, we can write 9 by 24 equal to y by 6. From here we will get y equal to 2.25. Then 5.625 divided by 9 equal to x3 by 9 minus 2.25, you will get x3. We can find x4 in the same way. 5.625 divided by 15 equal to x4 by 15 minus 3.75. So maximum bending moment at 9 meters equal to load into area under ILD. So load into 20 into area of a trapezoidal plus again load into area of trapezoidal. So we'll get 590.58 kilonewton meter. So next, absolute bending moment. We know maximum bending moment, absolute means at center. So bending moment at 12 equal to 12 meter equal to L minus A by L into A, that is 24 minus 12 by 24 into 12, that is 6 kilonewton meter. Then we'll find the ordinates x5 and x6. UDL is also at center. So maximum bending moment at 12 equal to load into area plus load into area of trapezoidal. Then we'll get 630 kilonewton per meter maximum bending moment at 12 meters.